All right, we're going to do an example or two of some of the business applications for equations and functions in the business world. So things you might see as you move through your courses, things you're certainly going to see in this one, but would be applicable in, say, an economics class or something like that. So it's not just for this math class. You will see it as you move forward. So the first one I'm going to do, the biggest one I'm going to do is about supply and demand, and then we'll talk about a couple of other little points. So here's your example. Your example says that you're looking at two different things. One is supply. That's the people who have the items that they want to provide to the market, and they want a decent price for it, right? You took your time creating this object or manufacturing this object or whatever. And in this case, we're talking about the supply of boxes of oranges. Okay, so think an actual farmer's market or something like that. Okay. So they've done a little bit of market research. There are companies that do marketing and stuff like that. They do surveys, all kinds of things. And what this problem says is that they have decided that at $9 per box, the supply of boxes of oranges would be 320,000 boxes of oranges. Okay. And the demand is 200,000 boxes. Okay. So what does this mean? How are they finding these numbers? Okay. What they did is they went out and they talked to the people who were supplying the boxes of oranges. That's people who picked them or got them off their farms or whatever they did. Okay. And what they're saying is, if we set the price at $9 per box, because it's an open market, so people get to decide what they're going to charge for these things. But if you set the price at $9 a box, then I, as the supplier, am willing to provide 320,000 boxes of oranges. Okay. So this could be like a co op situation or something across the nation. Okay. But the problem is at $9 a box, okay, supplier, you have $320,000, but the demand is only 200,000 boxes. Okay. So the market, the people who are coming to the farmers markets and who are going to the grocery store and all that, when they see it's $9 a box, they're like, I'm not really wanting all 320,000 boxes that you have. I only want to purchase 200,000 boxes. Okay. So that's different people in different farmers markets or whatever, but they're like, we just really don't want to purchase all of those because it's $9 a box, and that's a little bit more than what we're willing to pay. Okay, so that's one thing. Okay, the other piece of information that we got from the marketing office was that at $8.50 per box. So again, they've done some surveys or something like that. So basically, they said, well, what if we drop the price? Okay. So at $8.50 per box of oranges, still oranges. Okay. The supply, I'm going to use some of my shorthand here. The supply is 270,000 boxes. Okay. So, okay, if you drop the price a little bit, I'm not really willing to sell you quite as many oranges. Like I'll hold them back. Maybe I'll put them in a refrigerator or something like that. I'm not quite willing to put 320,000 on the market, right? But so I'm going to drop my supply. I'm only going to put out there on the market $270,000, okay? Or 270,000 boxes, sorry. And the demand is 300,000 boxes. Okay, so that's a different price point that they have found with their research. So here's what they're saying. All right, up here, if we price them at $9 a box, we've got more supply than what we do demand, right? There's more on the market. It's kind of like flooding the market. People aren't so interested in them. But if you drop the price to $8.50 per box, well, I'm not willing to give you as much, so I'm not flooding the market. I'm kind of holding back. It's still a lot of oranges, but it's not as much. And now the demand goes up. Well, why does the demand go up? Because the price went down. Yeah. So I'm more willing to buy a box of oranges at $8.50 a box than I was at $9, right? So there's this constant thing in the market where, okay, supplier, what are you wanting for your oranges? Okay, purchaser, okay, market people, what do you want to pay for these oranges? And we're always trying to find what's called an equilibrium point. Okay. So on this one, when it was $8.50, the demand was high, but the supply was lower, right? So we don't want a surplus of oranges on the market, but we also don't want a deficit of oranges, right? We want to have a nice equilibrium. So we're looking for an equilibrium point. That's where we're headed eventually. Okay. And what does that mean, equilibrium point? It's kind of like the break even point we talked about before, where um, cost equaled revenue for break even. But here I'm looking for an equilibrium point between supply and demand. So basically, what we're saying is we really want those two to match, right? Okay. So if $9 is too much for the buyers and $8.50 is too little for the suppliers, then maybe somewhere in between there, everybody will be happy. That's what we're looking for. Can you meet me in the middle kind of thing? And that's what the equilibrium point is going to be. Okay. So in reality, what's going on is we have two equations here. We just don't know it. Okay. Two equations. And they're both called price equations. One is for the supply and one is for the demand. Okay. So this particular problem first says find the price supply equation. Okay. And by the way, we're going to talk in thousands of boxes. Okay. I don't want to be writing 300,000 boxes all the time. Right. So I'm going to talk thousands of boxes. And I'd just like to make a little note somewhere so that we remember that, okay, these numbers are smaller than what we started with. Okay. So here's what I know. I know that I'm looking at supply, right? Okay. So I know that whenever I had 320,000 boxes to sell, the price that went with that was $9 a box. Okay. So the independent thing here is I'm giving out 320 and the dependent is $9. Okay. If you're willing to give me 320, I got $9 for that. Okay. The other thing I know is when it was $8.50 per box, we had 270,000. Okay. So that's why I don't want to write 320,000, 270,000. I'm just writing the number and we'll know that, hey, we're talking thousands of boxes. Okay, so this gives me 2 points, right? And if I have 2 points, I ought to be able to make an equation. Let me put a little note here. I'm sorry. Um, X is the number of oranges, and the second thing is the price, right? Okay, and the price is depending on how many oranges. So that's what we're talking about. And in fact, we've got boxes of oranges and the price of the oranges. That's what we're talking about here. Okay, so that's what we're looking at. Okay, number of boxes of oranges, here's the price. All right. So I've got 2 points. We're looking for a price equation, price supply equation. So I think I can do this. I think we can just say, hey, what about the slope, right? So I got x1, y1, x2, y2. We want an equation. So let's start with slope. M equals y minus y. So 9 minus 8.5 over x minus x, 320 minus 270. Again, if you're doing this, just make sure if I started with the 9 on top, I have to start with the 320 on bottom. Those numbers have to be from the same point. They have to line up, so to speak. Okay, that's 0.5 over, I think that's 50. Okay. And I feel like we can probably do this math, but just be careful with it. I'm going to move this decimal over because I don't like having the decimal in the equation. But if you do that, you need to add a 0 or move a decimal here. So I think this is 5 over 500 or 1 over 100. 0.01. Okay. So just to make sure everybody understands what I just did there. Okay. 0.5, come over. Divide by 500. Oh, I'm sorry. It was divide by 50. I made it into a 500. Sorry. 0.01. There we go. Yep. See, we all make mistakes. All right. So it was originally this guy. And I moved the decimal over 1, right? Okay. So it's a 0.01. That's what we've got. That's my slope. Okay. And then we have 2 points here. So I can totally use the point slope formula, which is, if you remember, y minus y1. Well, I think I'm going to keep going with this guy, y minus 9 equals m. Well, I know that's 0.01 times x minus the x that went with this guy is 320. Okay. And now I've got a couple of things I can do. You can totally get rid of your decimal and stuff like that if you want to. I feel like I'm going to go ahead and distribute this. Y minus 9 equals 0.01x minus the 320 times the 0.01. Does everybody agree that that's like dividing by 100? So this is going to be 3.20, but we don't care about the O at the back of a decimal. Okay, so 3.2, you can divide or multiply that if you want to, 320 times 0.01. And then the last thing I think I need to do here is add the 9. That'll go away. So what I'm getting, I'm going to put it right here. Y equals 0.01x. And I need a 3.2 negative 9 minus 3. Oh, 9 minus 3.2. Okay, 5.8. And it's positive. And again, this was on the supply end of things, right? Okay, so I also need a demand on that. Okay, so I need that other end of things. I'm out of paper. Give me a second. Sorry. All right. So that was my supply function, but using the same information here, right? We have these 2 pieces of information. We also know stuff about the demand function. So part B says, write a price demand function. Okay. And to do that, we need to use this other information, right? So when it was $9, we had 200,000, right? So I think I can do the points 209 and 850. We have 300 and 850. And again, realizing that I'm going to do thousands of boxes, right? So I'm still working the same way. This is using X and then the price of X, right? That's what I'm after. All right, so looking at that, the process is basically the same, right? M equals, I'm going to go 9 minus 8.5. And then on the bottom, I've got 200 minus 300, 0.5. And hey, hang on a minute. That's a negative 100, right? Okay. So using a negative 100, we realize that all of a sudden my slope's going to be negative. So this guy's a decreasing slope. So 0.5 divided by negative 100 gives me 0.005, and it's negative. Okay. So there's my slope for that. Is everybody okay with that? Okay. If you're not sure, go back and plug it in, use your calculator, that kind of stuff. It'll be all right. All right, so now my formula or my function, my equation, I'm sorry, y minus, I'm going to use this guy again, 9 equals m, which is negative 0.005. Let me make that clear. It's a negative. X minus 200. Okay, again, distribute that guy. Y minus 9 equals negative 0.005x, and a negative is a positive. And let's just do this on my calculator to make sure I got it okay. -1, is that okay? Oh, I'm sorry. +1. Negative and a negative is a positive. And now I just come in and add the 9, right? That goes away. Oops, this was a y. Y'all shouldn't let me make silly mistakes. 0.05005, that's the same y. Sorry, I just wrote it wrong. Plus 10, right? This guy right here. Okay. There's that equation. Okay. So I got my supply. I got my demand. And these are price demand functions, but specifically they deal with whichever one is whichever, right? And then the last thing that this particular problem asked me for is part C, find the equilibrium point. And like I said, we're going to set these equal to each other, right? Because we want both sides to be happy. We want the supplier and the buyer to both be happy. So I have y equals 0.01x plus 5.8. That was one of my equations, right? That was the supply one. Yep, supply. And then I'm going to set that equal to this one that I got for demand right here, negative 0.005x plus 10. Okay, and those are going to be a little tricky just because of the decimals. If you don't like the decimals, you can clear them out. I'm going to move all of my x's onto the other side so that those will be added right there. So let's get that up. 0.01 and it's plus 0.005. So I'm getting 0.015 x. And then, of course, I'm going to subtract this 5.8 out to get rid of him. Okay. And on that side of things, I've got 10 minus 5.8. I believe that's 4.2. Here's where I am. And last but not least, get the x by himself. Okay, he's being multiplied, so I'm going to divide him. That's x equals, and we better do this on the calculator so we get it right, because that's a big number, okay, or a lot of decimals. 4.2 divided by 0.015, and I'm getting 280, okay? So if you need to push pause, I'm sorry, I'm trying to get this done real quickly. If you need to push pause on that one, go back and push pause. Make sure you can do that calculator work on your own. But basically, what is this saying? 280,000 boxes of oranges. That's where we're going to be at an equilibrium point, right? And the very last thing is you can use either of these price supply or price demand, okay, to figure out what it is, what the price needs to be, just by plugging in the 280, right? That'll tell me. So if you multiply that guy out, add the 5.8, Okay, it's $8.60. That's the equilibrium price. Okay. So you can go back and that one I use the supply equation, but you can go back and use the demand equation and still get there and you'll be just fine. All right. So you better get the same price as I just got, right? Because it's the same, it's a different equation, but it's supposed to be equilibrium. It's supposed to be where they're the same. So there you go. All right. I hope that gives you a good understanding of the business applications for this stuff. And good luck on the homework. We'll talk to you soon.